Hello everyone, this is Emil Naruto. Welcome to my channel. So today in this video, I'll be talking about data structures. So, for example, earlier we have discussed about variables in the sense x equal to maybe ML Naruto and y equal to 20.5, a equal to 18. So here x, y, a, all these are variables. So now we have data in our variables. Now, what do we need? We need a particular mechanism. Okay. Why do we need a mechanism? We need a mechanism to manipulate these data. To manipulate these data, we need a mechanism. Okay. And why do we need to manipulate this data? Why? Because, for example, see here, we have a specific problem here. We have a specific problem. Okay. For example, this is a problem. Maybe problem one. And if we want to solve this problem, we have this is our whole data. Okay. Wherein we'll be having some good amount of information here in our data. This is our entire data. Okay. If you want to solve this particular problem, then what do you need to do? You don't need this entire data. You can only maybe you can only require this particular data. Okay. And out of this particular data you will only be working on this amount of data. So depending upon the problem and depending upon the requirement, or the depending upon what the problem is actually demanding, so we need to manipulate the data accordingly. Okay. So depending upon the problem, we need to manipulate the data here. We need to manipulate the data accordingly. So if you want to manipulate the data, we need a particular mechanism. Okay. So if you want to manipulate some data, you need a mechanism, and that mechanism is nothing but data structure. Data structure is that mechanism with which we can easily manipulate the data to solve any given problem. Okay. So now if you ask me what is meant by data structure, just give me the table definition, I mean textbook definition, then I can easily say that it's a kind of a special, it's a kind of a special way with which we can store or organize data in the computer memory or in the computer. Okay. So this is the definition for a data structure. So it's a kind of a special way. Okay. It's a special way of organizing and storing a data in our computer. Earlier, I have told you that we need some mechanism to manipulate the data. Manipulate in the sense storing and organizing the data in our computer memory. So that's nothing but a manipulating. So if you want to manipulate some data, you need a special kind of way, which is nothing but a particular mechanism. That mechanism is nothing but data structure. What happens if you manipulate the data in the computer? Then that can be used in an efficient way to solve any problem. Did you get that? So now I'll tell you about how many types of data structures are there. So these are the data structures, types of data structures. We have arrays, files, trees, graphs, linked list, stack, and queues, and so on, maybe, etc. There are so many. So these are the most popular types of data structures actually. So now these types of data structures are classified. Okay. For example, how they are actually classified based on organization, based on the organization of the data. Okay, based on the organization of the data, how your data has been organized. Depending upon that, our data structures. In short, I'm actually mentioning it as DS. Okay, in the sense data structures. Just remember this thing. DS data structures are classified into two types. What are those two types actually? So the first one is linear data structure. Okay. So what is meant by linear data structure? In this, the data are accessed, or we can call it as elements. Of course, data elements. So data elements or elements are accessed in a sequential manner. This term, sequential manner, is very much important. If you miss this sequential order, then the meaning of this entire thing would be changed. Seriously. So just remember this particular word, that is sequential order. In the sense, elements are accessed in a sequential order, but it is not mandatory that these elements are stored in a sequential manner. Okay, for example, I'm saying here elements should be accessed in a sequential manner only. Okay, this is the mandatory thing, but it is not mandatory. It's not. It's not mandatory that elements are stored in a sequence. Okay, so only accessing the elements in a sequential order is a compulsory thing, but it's not at all mandatory that these elements can be stored without following a sequence. So they can be stored in a random way. Okay, it's not mandatory to store these elements in a sequential way. Okay, then it is called the linear data structure. So here also we have few examples for this linear data structures. Those examples are linked linked lists and stacks and queues. Okay, so linked lists, stacks, queues, all these three are the examples of linear data structures. Now, the second type, would be non-linear data structure. Non-linear data structure. The name itself, it is actually explaining that it is not linear, in the sense it doesn't follow sequential order. Okay, in the sense elements are stored. Okay, elements are stored or accessed in a non-linear order. Non-linear order in the sense non-sequential order. Okay. In the sense these elements will be stored or accessed, but not in the linear order. Okay. These may be random. Okay. So these are the two types of data structures, and here also in the non-linear data structures we have few examples of it. For example, trees and graphs are the two examples that belong to non-linear data structures. Okay. So in this video, in total, I have explained what is meant by data structure and how the data is stored or accessed. I mean, depending upon which criteria this data structure usually happens, and what are the types of data structures. There are two types: linear data structure, and the examples are linked list, stacks, queues. Linear data structure in the sense it's it is actually very much mandatory that the elements are accessed in a sequential manner, but it is not at all mandatory that the elements are actually stored in a sequential manner. In the sense, elements can be accessed, but only in the sequential manner. But it is not mandatory that it can be stored in a random way, not in a sequential manner. So this comes under the linear data structure part. But here, and the examples of it are linked list, stacks, queues. But here in the non-linear data structures, it is not at all mandatory to store or access the elements in a sequential manner. So it never follows the sequential rule. It only follows the random way. So the examples for it are trees and graphs. So that's it about data structures. So I'll see you in the next video. If you really like this content, just share it with your friends, and I'll be uploading more videos. More videos are actually coming soon, and I'll be uploading many videos related to many more technologies. So just feel free to subscribe and share it with your friends. I'll see you in the next video. Take care. Jai Hind.